Okay, so here's a problem we're going to draw the shear and moment diagram for. Let's do a little bit of strategy first. If you look at the external reactions here, we've got a pin at A and a pin at D. So what does that tell you about trying to draw a free body diagram for the whole structure? Well, you'll have two unknowns at A and two unknowns at D. You won't be able to solve for them all. It's like, well, is this an indeterminate problem? No, because it's a little tricky, but right here, this is an indication that this connection does not have moment capacity. So we know the moment there is zero. So we'll just have a horizontal and a vertical force. So if we take it apart into two free bodies, this L-shaped one, it's not really an L shape, inverted L, and this vertical piece, I'll generate 6 equations, 3 for each body, and I'll have 2, 4, 6 unknowns. So it is a determinate problem. So we'll have to go through and do all that statics first. So I guess we'll get started. Let's see. I think I'm going to go ahead and take it apart. So I'm going to do a free body diagram for this section CD. So if I were to take CD, I'm going to assume at C that I have a force in the X direction and a force in the Y direction. Then down here at D, I'll have reactions dy and dx. And one thing you can see about this is how many unknowns do I have? 4. And I have how many equations? 3. So I won't be able to solve for them all. I'll have to come back and do some other things. And I don't want to forget my applied 60 kip foot, and this thing is 12 feet long. So let's see what I can get from this. I'm going to start by summing moments at C. And making sure everything's in equilibrium. So when I sum moments at C with right-hand rule, of course CX and CY create... Did something flicker?
Yeah, the screen just...
Okay. So CX and CY don't create any moment. DY passes through C, so the only thing that creates moment is dx. And that's positive moment with a moment arm of 12. And then I have the applied moment, which is what? Positive or negative? With right-hand rule. Right-hand rule. Negative. So I can solve that. Dx is equal to 60 divided by 12, which I think is 5 kips. And it came out positive. So now I can come and sum forces in the X direction. And what will I find? Well, I got CX to the right, plus DX to the right, plus nothing. So CX is minus 5 kips. The last thing I can do here before I leave is I can sum forces in the Y direction. And what do I have? Well, I have CY acting up, and I have DY acting up, and that's it. Now I can't solve for those, but I can find out that CY will be equal to negative DY. So I get a relationship. I don't get a value. So that means any time later I find dy or cy from something else, then I have dy. Okay? So now let's draw a free body diagram for the other piece, A, B, C.
And why don't you take it apart?
Sorry?
Why don't you...
Well, right now it's fixed. I'm just trying to find all my reactions to get started. I will have to come back and break this apart.
Gotcha.
And that would be a good idea to do if I already had everything I knew at C. But what if I break it apart at D? That's 3 unknowns, and right now I don't know CY. That would still be 4 unknowns. So you just kind of have to work your way through it. It flickered again, didn't it?
Yeah. Yep.
Oh well. As long as it doesn't flicker and stop and it goes dim and dark. If it goes dim and dark and stays that way,
We're dead.
sorry. More than likely the earthquake has come. Oh, by the way, I went to Reelfoot Lake last week on Tuesday. That's a really big lake. And the last earthquake created that really big lake.
Did you see the eagles?
I saw the eagle. So as I was staring at that lake, I was thinking about the magnitude of the earthquake that created that lake.
It's only a couple feet deep, though.
But it is huge.
Maybe I don't know how big it is.
It's very large landmass. And considering it wasn't there before, and now it is there.
Yeah.
And according to the natives, that Native Americans, well, I guess they were Americans then, you wouldn't really call them Native Americans. The indigenous peoples, the Mississippi River flowed north for a day
When that happened.
to fill the lake up.
Wow.
That's the legend, anyway. You know, in 1811, there wasn't a lot of eyewitnesses around. The ones that were maybe didn't.
We're running
away.
east and west.
Supposedly there were some trappers in the area, some early trappers, and they felt it. Supposedly, it rang a bell in a church in Boston.
Wow, I've heard that.
Whether that's true or not, I mean, it's 1811.
I mean,
Go to Indian restaurant.
You got to remember, too, alcoholism was rampant in the United States.
a bunch of fur trappers.
That's right. Okay, so AY and AX. Well, speaking about the fur trappers, that was a solitary endeavor. So can you imagine spending your life hunting animals down, skinning them in the woods by yourself
Sounds fun.
with little contact with humans? What kind of person would that generate? If you did that today, we would think very poorly of you. Okay, so so let's talk about what we have for happening at the other end at C. Yeah, I assume CY was acting up here, so that means CY has to be acting down. Now, I assume CX was to the right, but I found a negative value. So CX would be in this direction. And I'll let the negative sign work its way through my equations right now. So there's my reactions. In addition, I have the 15 kip load located in the middle. And I have this distributed load, which if I do a concentrated equivalent of that, what would that be? 36, right. Area of the curve would be 3 kips per foot times 12 feet, and then that would break that up into 6 and 6. Okay, so far so good. Now, I'll just go ahead and remind you that we know CX. We found CX already, right? We don't know CY, we don't know AX and AY. So how can I find something quickly?
Sum of the forces in the X direction.
Could sum the forces in the X direction, I get AX. What else could I do? I would take a moment about A because I don't have to worry about A, and then I have only one unknown, CY. Of course, when I find CY, I have found DY. Am I doing that? Am I touching something?
No.
Just doing that.
Okay. Oh well. All right, so let's sum moments about A. So my applied force, my 36 kip force, is creating negative moment. So 36 kip force at a moment arm of 6 feet. How about the 15 kip force, positive or negative? Negative. So that's 15 kips. Its moment arm is 4. Then I have CY acting down, which also creates negative moment with a moment arm of 8. And then I have CX, which actually creates positive moment in this configuration. And it has a moment arm of the height, which is 12. Looks like one equation and two unknowns, but we know CX. So if you put a minus 5 in here, you should be able to solve for CY. Can somebody do that?
purposefully draw CX going in the opposite direction?
No, well, it's equal and opposite, right? I assume to the right at CD it has to be equal and opposite on this
But
body.
we found it to be negative.
I'm going to put my negative value in right there.
Oh, so you're just going to use the negative.
Yeah, I could have drawn it as a 5 kip force to the right.
Okay, I was just making sure.
Yeah, I didn't want to do that. I wanted to just leave it the way it was.
Okay, thank you.
Yeah, 42.
I don't know. Did anybody else get 42? Hopefully it came out positive, right?
Yeah.
Okay. So what else do I need? Well, I think now that I have CX and CY, I can just sum forces and I'll have AX and AY, right? So let's do the vertical forces first. So if I sum forces in the Y direction, I've got AY acting up, minus CY acting down, minus 15. Is that it? I think so. So that means that AY will equal 15 plus CY. That's not right. AY is up, CY is down. That's right. Yeah. So what's that going to be? 57? Yeah. That makes me nervous.
Sounds that right?
And I think so. Let me think about this. Let's go back and check this for a second. Did I do CY right? Let's.
Boy,
You sure CY didn't come out to be negative?
I get negative 27.
negative 42.
I don't like this being positive. That means down is correct.
It's negative 42.
It's negative 42. Ah, I like that much better. So negative 42.
Yeah, but negative 42 divided by...
That means listen, hang on. That means that this force is actually up, and that makes a lot more sense. It's got to react this force and this force, which are trying to rotate it clockwise. So the direction, I think, is correct. Now, if it's 42 or not, you guys need to tell me.
No,
it's 42.
Yeah, it's 42. Positive or negative.
Okay, so now when we put that in here, this becomes a positive 42. And so AY is going to be the difference between 42 and 15, which is 27, right? You got 27?
Yeah, I got 27.
You got 27 for CY?
Yeah.
No.
That's what I got.
Let's try it again.
I got a positive 42 for you.
You might want to pause the video for a second.
Do I need to bring my calculator? Don't forget that CX is negative 5 in my
which gives you
equation.
a negative 60.
Negative 42 is what my calculator says.
Okay, everybody gets negative 40. So this would be 27.
How are you getting negative 42?
I just pressed solve, and that's what it gave me.
Jesus.
Well, I know it should be negative.
Right, so it is negative.
It's just as long as what's the value. Did I write my equation correctly? Let's check.
Now I have negative 42.
That's right.
Negative, 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 positive.
It's the sign convention because you kept negative 5. Negative 5.
Yes, CX needs to go in as negative 5.
Yeah, that gives you negative 60
This
plus
gives you
negative
negative
60
60.
plus the negative 216.
Well, all these negative values go to the other side and make
Which
them
becomes a positive
Yeah,
33.
something's not right.
No, that's what I'm saying. The CX that you have circled.
Oh, negative 42 makes sense.
Yeah, it's negative.
That's right. But
Yeah.
see, I assumed it's down. So it's actually up. And up is physically correct.
Right. So it's supposed to be 42. Up.
Negative 42. The way I assumed
That
it,
sign
but it's
convention.
actually up.
Right.
So what's AY supposed to be? AY should be down. Negative 27.
Minus the negative.
Yeah. That's right.
Okay. I like that better. That was interesting. So what's happening here is this is one of those situations where because of this overturning, the frame is trying to rotate up. So AY is actually having to pull down to keep the structure from lifting up. This is uplift. Because this is a pretty high horizontal force compared to this vertical force. This is what happens when you have high winds, possibly. Okay, that was interesting. So we got one more to do here. We're going to sum forces in the x direction. And according to my free body, that would be AX minus CX plus 36. Now remember, CX is negative 5.
Negative 41.
That's what it looks like to me.
That makes sense.
It makes sense that it's negative. Oops, I lost my 90 sign, sorry. It should be negative 41. So we've just spent, let's see how many minutes is that. That's 15 minutes, and we're not halfway through. Because now we have to break it apart at B and find what's happening at B.
So for test 2,
And then we have to draw all the shear moment diagrams.
So for the test, we could have 8 questions. Once.
Well, this might be a more challenging problem than you would expect on the exam.
I would pick this one.
Okay, so I'll keep this stuff handy, and let's slide over here. And let's break it apart at B. So when I break it apart here at B, I don't know. I think the easiest one to work with would be the section BC. So I'll draw a free body diagram of section BC. When I do that, I have the applied load, 15 kips, at 4 feet and 4 feet. Now, I already know everything that's happening at C, right? If you look back, you'll see that CX was minus 5 kips. So that means it's actually in this direction. CY was minus 42, which means it's in this direction. Okay? Now I have the new things that I'm going to deal with. So I'm going to come over here at B and assume BY up, BX to the right, and I'm going to assume a positive moment at B. Positive in terms of right-hand rule. 1 free body, 3 unknowns. So let's start by summing our moments at B, making sure it's in equilibrium. So BX and BY pass through point B. They don't create any moment. So I have my moment B, which in my sign convention is positive. What about the 15 kip force? Is that positive moment or negative moment? Negative. 15 times 4. What about this 42 force? Positive or negative? Positive. So 42 kips times a moment arm of 8. And of course, CX passes through that point, concurrent at B. Excuse me, so it creates no moment. So we should be able to find the moment here. It looks like it's going to be a large negative number. That should be 336 minus 60, which is, what is it? 1? I'm guessing.
276.
276? I like that. And that's kip feet. Okay, I can sum my forces in the y direction. And what do we have? We have BY acting up, minus 15, plus 42. Right? 15 kips down, 42 kips up. So BY is
Negative 27.
negative 27.
Right.
Yes.
BY plus, yeah.
That makes sense. No.
That's right.
Yeah, it does. Have to think about that one. And then we can sum forces in the x direction. I'll assume to the right positive for my sign convention to do my statics. So I have bx to the right, positive, and then plus 5. So it looks like bx is negative. So finally we have all the information we need to draw the shear moment diagram.
So you're dead if you know this one.
And that's only took 21 minutes.
You're not going to do as one of this one test.
Of course. I think I'll give you 4 of these.
I think I'll give you 4 of them. Why not?
Okay. I think I've got room to draw 2 of them on this sheet, and then I'll have to do another sheet. So let's start with AB. So we'll go up here, and we'll do section AB. So I'm going to rotate it so that it's horizontally oriented. So that horizontal force now becomes a vertical force. So I'm looking at A. So what was AX is now going to be in this direction. And we saw for AX as negative 41. Right? So that means it's in this direction. 41 kips. What's the moment at A? Well, it's a pin, so it's 0. So now we go to B.
I don't understand that. How can you say there's no moment at A, but there's a moment at D?
Well, D has an applied moment. So somehow we have a loading configuration or something attached where it's applying a moment there.
Okay, so you can have an applied moment.
Remember, this is the moment in the structure, not the moment at the support. There is no moment at the pin, but just inside the structure, there's that 60 kip foot moment.
Gotcha.
Just inside the structure A, there's no moment. Okay. So we go over to B, and we found, let's see, so we want the force in this direction, which would be Bx, and we solve for Bx as negative 5. So if it's to the right here, that means it's going to the left there, which is up, but it's negative, so it's down. Did you follow that?
Yeah, that was a good one.
Okay. This has a length of 8. This is 3 kips per foot. Now, what's the moment at B?
It's 12.
Okay, so on BC, it's
12 feet. Sorry.
I assumed positive clockwise, so that means it's counterclockwise here, but it's negative, so that means it's actually clockwise.
No, I mean, it's 12 feet long. AB is 12 feet long.
Oh, I see what you're saying. Sorry. I glanced up here and saw 8. So this is 276.
If it's negative, like a can.
Well,
Isn't that
okay.
positive?
No. At B, using right-hand rule, I assume positive.
Okay.
So that means at the top here, it's negative right-hand rule. But the sign of the value is
it's
negative. So that means it's back to positive right-hand rule.
Okay. Roger.
Sign convention. Okay, so I'm going to go ahead and sketch a template for this, and we'll attempt to draw the shear diagram and the moment diagram. So starting with the shear diagram, what's the shear here at the left side at A? Looks like it's 41. We'll start at 41. What's the shear at the right-hand side? It's not negative, it's positive.
Oh, yeah.
That's a tricky one. Now remember, our equation tells us that the change in shear is the area under the load diagram and that the slope of the shear diagram is the load. So starting with the area first, or the change, looks like our change is what? 36. Is that balanced by the load? Well, look at this load, 3 times 12, it is negative 36. So 41 minus 36 is 5. That matches. What's the slope? What's equal to the load? The load is constant and negative 3. So that would give us this constant slope, and if you actually matched it, it would be negative 3 to 1. So that's kind of a trapezoid. Well, it's not kind of. It is a trapezoid. Now we'll come and draw the moment diagram, which will have units of kip feet. The moment at A is 0. The bending moment at B is, well, let's look at this moment. We know it's in this direction, 276. Is that a positive or negative bending moment? Positive. So that means we need to land at 276. Now our relationships tell us that the change in moment is the area under the shear diagram. What's the area of a trapezoid? The easiest thing to do is to average the heights. So that's 46 divided by 2 is 23. And 23 times 12 is 276. Someone needs to check that. But I think it is. This is positive. So that means we start at 0, we add 276, we hit 276. Great. Our second relationship, the derivative relationship, tells us that the derivative of the moment diagram is the shear. So we start here and we see that the shear is large, 41. So that means we're going to start off at a large slope, and it's going to decrease to not a 0 slope, but a less shallow slope. So you get something that kind of looks like that. I didn't get it quite right, but you get the idea. It's not 0 slope there. It's still kind of on the way up.
Why is there no midpoint?
Why is there no what?
Why do you not have to find X in this situation?
And we never crossed the axis.
Well, why would it not cross the axis?
It just didn't. That's just the way it is.
It just did.
This beam has all positive shear and all positive bending moment. So let me see if I can squeeze in section BC. I think of all the ones we're going to draw, this one might be the easiest. So we have an applied force of 15 kips. The distance is 4. Now we already solved that diagram here, so we can just put these values on it. So what is BY? We found BY to be negative 27, so it's actually down. We found the moment to be negative 276, so that means it's opposite 276. What's the moment at C? 0. What's the reaction at C? 42 up. See that? I may run out of room here. What time is it? Holy cow, class was over 10 minutes ago. You guys didn't stop me.
Was it really?
Yeah. You know, it's kind of interesting that you were that engaged that you didn't even know the time had passed. Okay, so what I'll have to do is I'll have to stop this here, and we'll have to pick this up on
YouTube. I hate that one.
on Tuesday. So I'm going to go ahead and turn this off, and I'll post what we have.
Each